Good morning, good afternoon, good evening, or depending on your time and your location. I'm Engineer Moses Umafe. Today, I want to discuss on the topic solar system. Solar system. Now, directly or indirectly, the sun provides all the power we need to exist and support all life form. Deep in the center of the sun, intense nuclear activities generate huge amounts of radiation. In turn, this radiation generates light energy called photon. These photons have no physical mass of their own, but carry huge amounts of energy and momentum. Solar electricity, sunlight shine on the photovoltaic panel. A solar panel generates electricity using a photovoltaic effect, a phenomenon discovered in early centuries. Two layers of these semiconductor materials are combined to create this effect. One layer has to have a depletive numbers of electrons. When exposed to sunlight, the layer material absorbs the photons, excite the electron, causing them to jump from one layer to other, generating electrical charge. Now, for us to use this electrical charge effectively in safe manner and reliability and to ensure a proper functioning of our system or in helping our system design, there is a need for us to calculate the load of the residential. And the best way to calculate the load is to use the best quality clamp meter. For instance, let's assume that a calculation using a clamp meter of 600 amps. We can calculate the power consumption of home in our residential or even in our industry. To achieve this, we turn on all our appliances and use the clamp meter in each phase, which will show the power consumption in ampericity. We record the power consumption, like for instance, like 5 amp, 10 amp, respectively. By using the formula of power times current times voltage in a single phase, but in a three-phase, you use power times current times voltage times the power factor in three-phase. Now, assuming our clamp meter in this residential read 3.7 amps. For us to calculate this, we have to say power times voltage times current. We impute our voltage, which is 220 volts, multiplied by the ampericity, which is 3.7. And by the time we multiply this, the load of our residential is going to be 800 watts. Now, we assume that the load of our residential is 800 watts. I want us to go through this very particular installation setup of a solar system. Now, a solar system is installed at where you can have access to a ray. Now, the solar panel is connected in parallel and in series. In turn, connects to the input of the charge controller. The charge controller output is connected directly into the battery. And from the battery, you connect it into the input of the inverter. In turn, the inverter will convert the DC to what? AC, supplying our residential. Now, we have to calculate the inverter rating. For us to calculate the inverter rating, first we need to know what is inverter. An inverter is an apparatus device which converts direct current into an alternative current. An inverter rating should be calculated based on the following principle. An inverter rating should be greater than what? 25%. This is a standard. So for us to have this, the load times the percentage. Now, inverter rating, load plus 25% extra. So assuming in our residential we have 800 watts, just like we have rightly calculated, we multiply 25% times 800 watts is going to give us 200 watts. When you add 200 watts to 800 watts, it's going to give us what? 1000 watts. So for the load residential of 800 watts, you go for an inverter of 1000 watts in your design. Now, there is a need for us to also know how to calculate the required numbers of batteries and backup hours of battery. And for us to do this, we need to know what is battery. A battery is a container consisting of one or more cells in which a chemical energy converts to electrical using a source of power. This size of battery is directly related to a storage capacity. And this storage capacity is the energy stored in the battery, which is multiplied by the voltage of the battery times the battery capacity. And for us to know the energy stored in the battery is by multiplying the voltage of the battery times the battery what? AH. And when you multiply 12, which is the battery voltage, times 100 AH of one battery, is going to give you 1200 watts per hour. So how do we know the backup power? The backup time of one battery is the energy stored in a battery divided by the load of the residential. And our load of the residential is 800 watts. So therefore, 1200 watts hour divided by 800 watts, which is going to give us 1.5 hours. Therefore, for us to calculate the backup time of this very particular battery, we have to first of all know in our design what are the days of the of autonomy in the area where we want to do the installation, where we might not have enough sun to charge the solar system. So we need 3 hours in this scenario to what? To have for our what? Backup hour. So because we have calculated the backup hour or a backup hour of one battery in the residential of 800 watts hour to be 1.5, therefore we divide 3 hours divided by 1.5, which is going to give us 2. So therefore we need 2 batteries to give us a backup hour of what? The 3 hours we require. And how do we know this? First, we have to divide 2400 watts hour by the load of the residential, which will give us what? 3 watt hours. So for us to have the day of our autonomy, which is 3 hours effectively, we have to connect the 2 batteries of 12 volts, 100 AH in parallel for our effective operation of our backup hour from the battery. Now, we are not going to stop there. First, we need to know how to calculate our charging current of a battery and the charging time required. For us to calculate the charging current of the battery, first we need to know what charging current is. Charging current is a current that flows through a shunt capacitance of a transmission line. The required charging current for a battery is reciprocal of 10. So assuming that the battery capacity is 100 AH, the multiply by the reciprocal of 10 is going to give us what? 10 hours. So 10 hours is our battery time, and why 10 amps is our charging what? Current. And for us to know this, we have to also put in consideration of 40% loss during charging. And because of 40% loss, for us to introduce a fast charger, we need to add 2 to it, making it what? 12 amp. Then for a slow charger, you can use the what? 10 amp as rightly calculated. We're not going to stop there. There's a need for us to also know how to calculate the required numbers of solar panel. And then first, we need to know what solar panel. Solar panel are those devices which are used to absorb sun rays and converting them into electricity or heat. They are for a collection of solar photovoltaic cells, which can be used to generate electricity through photovoltaic effect. However, the required numbers of solar panels must be calculated to ensure an accurate supply of electricity. By using the formula, power equals to voltage times current. Now, the power here, the battery voltage multiplied by the charging current. Now, we assume that we have 12 volts and our charging current is 20 amps for the 2 battery, which is going to give us what? 2400 watts. Now, assuming one solar panel power is 60 watts, and note that all solar panels are designed in a rating of 60 watts or 120 watts or more. So assuming you purchase the solar panel in this scenario of 60 watts, for you to know the numbers of solar panel is equals to, you have to divide the power rating of the panel, which is 240 watts, divided by 60 watts, will now give you what? 4. That is to say, we need 4 pieces of 60 watt solar panel to ensure the effective operation of this load residential of 800 watts. And for you to do this effectively, all solar panels must be connected in parallel. I want you to watch out for other calculations relating to electrical through this very particular channel. Thank you.